If you're responsible for process development in biopharmaceutical harvest and clarification, you may be dealing with a lot of pressure to get a good commercial fit quickly while juggling many challenging variables at the same time. New industry trends in upstream processes are introducing higher demands on the harvest and clarification process. There are development and facility advantages for these processes to be increasingly flexible and scalable while still delivering high-quality end product. The flexibility and efficiency of a facility may be negatively impacted by an increased number of cell culture types and conditions required to produce an increasing portfolio of product types. Variable cell culture fluid creates a range of negative effects on downstream purification, including decreasing overall yield, antibody degradation, and aggregation. What makes this especially complex is that not all components of the cell culture fluid are completely removed by a single unit operation. The combination of the insoluble cells and cell debris, for example, mammalian, insect cells, bacteria, and plant, and the cell culture soluble components, for example, host cell and product proteins, host cell DNA, buffers, antifoams, and cell culture media, can cause challenges with established clarification technologies when the success metric is defined as consistent fluid quality for downstream purification. It is important for you to map the different interdependencies amongst the upstream and downstream unit operations so that the harvest and clarification operations can be right-sized to build an optimized process without wasted capacity and incurring additional costs. Even with a clear map of your project needs, selecting the right set of unit operations to meet those needs can be difficult, as many of the options being used today may come with some trade-offs. For example, extremely high removal of whole cells and cell debris with centrifugation or depth filtration may cause additional shearing of cells and an increase in host cell protein and DNA concentration. Alternatively, low shear unit operations may result in a large equipment footprint. Currently, there aren't many harvest and clarification approaches which result in a standard conditioning of the effluent fluid across a broad array of challenge characteristics resulting from various production scales and molecule types. Over the last 10 years, many biopharmaceutical companies have attempted to address challenges in harvest and clarification by taking a proactive approach to map end-to-end workflows and tightly define success outcomes. Many companies generate detailed feedstock characteristics, like nature of protein, and volume, like filter capacity targets, to set goals on yield, impurity removal level, and processing time. But even with these clear targets, there may be technological barriers to overcome for these solutions to work. Let's imagine that a manufacturer is aiming for 10 grams per liter product protein concentration out of the bioreactor, with cell densities greater than 20 million cells per milliliter. Concurrently, cell viability at the time of clarification has generally decreased to less than 50%. For this scenario, the increased cell debris and colloid content due to lower cell viability has led to decreases in sterile microfiltration membrane life. To manage these fluid conditions, the manufacturer considered tangential flow microfiltration, TFF-MF for short, to increase the microfiltration membrane life. However, this harvest technology displayed several shortcomings, such as reproducibility and reduction in capacity. Here may be the reason for these shortcomings. Even though TFF-MF processes are often designed to minimize the rupture and fragmentation of cells in the recirculation loop, the high cell density fluids result in increased cell shear and fragmentation. As a result, a secondary clarification depth filter may be required after TFF-MF to reduce the small particle load before sterile microfiltration. Although multiple link stages are common within harvest and clarification to achieve product clarity, each unit operation increases the potential for additional product yield loss. So, how do you overcome challenges presented by process interdependencies and limited design options? You build it on newer technologies capable of facilitating robust integration of multiple steps to simplify downstream processing. Giving yourself the flexibility of implementing newer technologies opens up options such as single-use centrifugation, depth filtration, sonication, and flocculants-based solutions, which may maximize the reduction of the contaminants and help to generate higher yield during the harvest and clarification of high titer cultures. Technologies such as upstream chromatographic filters may enable a cleaner downstream protein A eluent. Further, new harvest and clarification solutions may enable the reduction of the size and even potentially the number of downstream unit operations, which in turn may reduce operating costs. 3M combines advanced materials and applied science to offer innovative harvest and clarification design architecture. To learn how 3M can support your harvest and clarification strategy, visit 3m.com/bioprocessing to learn more about 3M Zeta Plus and M-Phase product solutions.